Now, in this video, we are going to take up one more problem on the projections of lines, how to solve the problem number 73 by using analysis and also by using the sketchbook. The problem is as one end of a line is 30 mm in front of VP and 30 mm above HP. The line is inclined at 40 degrees to HP and its top view measuring 60 mm is inclined at 50 degrees to XY line. Draw the projections of the line and determine the true length and its inclination with VP. When you are trying to analyze this problem, so here one end of the line is 30 mm in front of VP and 30 mm above HP. So when you look from the front view, we can see the distance above HP. So when it is, as we are looking from the front view, the image will going to be projected onto the vertical plane. So this distance will going to become 30 mm. So we mark this point as A dash and this as capital A. As we look from the top view, we can see the distance 30 mm in front of VP. As we are looking from the top view, the image is projected on the horizontal plane and we mark this point as small a and this as capital A. Once you get this, then the top view measuring 60 mm is inclined at 50 degrees to XY line. So from A, you measure an angle of 30 degrees, 50 degrees and to a length of 60 mm. You draw an inclined line, so you got the locus of B in the top view. So you join A and B with a dark line, so you got the top view. And the line is inclined at 40 degrees to HP. So as we know, this is the true inclination line. The inclination with respect to HP is seen in the vertical plane. So that means, so we have to make the line parallel. So to make the line parallel, you take the top view line and make it parallel. With A as center, taking the radius of AB, you are rotating so that you make it AB1 is the line which is parallel to VP. So once you parallel to VP, so then what happens? With A as center, you measure an angle of 40 degrees and draw an inclined line so that it will going to cut here. So you are going to get capital AB1. So when it is projected, that image will going to fall directly on this. So you have got B1 dash. Once you got this, so you have the locus of B in the front view. So once you get this, join A dash, B1 dash. So this will going to be the inclination with respect to HP. So as we are rotating this, what happens? The image is also getting rotated from, as we are rotating, this is the line which is in space. Now how to find out this space now? So as we have got the point, how I will going to get this point now? So you draw a vertical projector from B to the X here. And again you draw a vertical projector from here so that it is going to cut the locus of B in the front view and you mark this point as B dash. Then join A dash B dash with a dark line. So as we are projecting from B dash and as we are projecting from B, both these 2 points will going to intersect at this point and you mark this as capital A and B which is in space. So this is the one which we have already explained, which is the true inclination with respect to true length with respect to it is in VP. Now we need to find out the true length in the horizontal plane. With A as center, taking the radius of AB, you rotate it, make it parallel, so that both A and B2 are above HP by 30 mm. So when you look from the front view, the projection has been done from here. So obviously the image is also getting rotated in the vertical plane. With A dash as center, taking the radius of A dash B dash, you draw an arc such that both A dash and B2 dash has been above HP by 30 mm. So that is what we have shown here. Both A and B2 are above HP by 30 mm. So when you are looking from the top view, that image is projected here. So naturally this will going to be the AB2. So that means when you look from the front view, that projection has been shown here. When you look from the top view, that projection is shown here, so that it will going to cut the locus of B. So this is how we will be able to analyze this problem in 3 dimensions. Now how it will going to be considered in the stepwise. So how we can do is, first we will going to take the top view, you make it parallel. So once you make it parallel, here you just project this point. So from A you cut an arc of draw a line which is inclined at 40 degrees so that it will going to cut this locus line here. So you got this capital AB1. So once you get this, as we look from the front view, the image will going to be projected here. So you will going to get the locus of B in the front view. So this is the true inclination line. So this is how you will be able to analyze it in 3D here. So here when you make this line parallel, that is the top view line is made parallel, that is AB1 is parallel to VP. So you're going to get the true length in the vertical plane. So you draw a vertical projector from here, but we don't have the true length, but we know the true inclination. So with A dash, draw a 40-degree line so that it will going to cut this end projector here. You mark this point as B1 dash and draw a horizontal dashed out line, which is going to be the locus of B in the front view. Once you get the locus of B in the front view, it becomes easy to find out the top view and its true length. So as we got the top view here, once you get the front view, you make that line parallel. So that means with A as center, taking the radius of EB, you rotate it, make it parallel. As we got the front view, so this is the line in space, we are rotating like this. So what happens with A as center, taking the radius of EB, you rotate such that both capital A and capital B2 are above HP by 30 mm. So when you look from the front view, that image A dash, B dash is being rotated such that both A dash and B2 dash are above HP by 30 mm. So that is the projection what I have shown here. When you look from the front view, that projection is shown here. And when you look from the top view, that projection is shown here, such that it will going to be cuts on the locus of B in the top view. So you join A and B2 with a little bit thicker than the XY line. So this is how we will be able to analyze this in 3 dimensions by stepwise. Now, how the same thing has been given in the orthographic view. So you take the front view, you make it parallel. So that means A dash B2 dash is above HP by 30 mm. That is what we have shown here. When it is projected onto the horizontal plane. So that is the reason why we are projecting that in the horizontal plane, such that it will going to cut the locus of B in the top view, and you mark this point as B2. As we know that this line is parallel to HP, so you are getting the true length. So obviously this will be capital A and this will be capital B. Join A and B2 now with little bit thicker than the XY line. So this is how you will be able to analyze this problem in 3D and as well as in the orthographic view. Now we will try to solve this problem using the sketch form. So to do that, first we will going to draw the XY line and you mark VP and HP. Then you measure 30 mm above XY line and you measure 30 mm below XY line and draw horizontal projector lines which is parallel to XY line. So consider any point, you mark this point as A dash here and draw a vertical projector to the top view and you mark this point as small a. So this as capital A and this also as capital A. Now you from here, by using the protractor, you measure an angle of 50 degree with respect to this horizontal line and then draw an inclined line. By using the compass, you measure the distance of 60, cut an arc on that 50 degree line and you mark this point as small b, then join A to B with a dark line. So now we got the top view. So then we need to identify the true inclination, as he has given the true inclination with respect to HP. So obviously that inclinations can be seen in the vertical plane. So that means that is the true length line. If I want to find the true length in the vertical plane, that is in the front view, obviously that line has to be parallel in the top view. So with A as center, take the top view distance, which is AB, which is 60, draw an arc such that both A and B1 are in front of VP by 30 mm. So once you mark this point as B1, then from B1 you draw a vertical projector to the front view, and then with A dash as center, then by using the protractor, you measure an angle of 40 degree with respect to the horizontal, then draw an inclined line so that it will going to cut on this end projector. You mark this point as B1 dash, then join A dash B1 dash with a little bit thicker than the XY line. As we know that this top view line is parallel to XY, its front view is in true length. So you mark this point as capital B. Then once you get this point, now we need to, once you get the locus, then draw a vertical projector from B to the front view so that it will going to cut on the locus of B in the front view. Once you get this point, you mark this point as B dash, then join A dash B dash with a dark line. So now we need to find out the true inclination with respect to VP. So with A dash is center, by using the compass, you measure the distance of A dash B dash, you draw an arc such that both A dash and B2 dash are above XY line by 30 mm. So once you get this point B2 dash, from B2 dash you draw a vertical projector such that it will going to cut the locus of B in the top view and mark this point as B2, then join A and B2 with a little bit thicker than the XY line. and you mark this point as capital B. So this is the true inclination with respect to VP. So now we need to identify the true length and its true inclination with respect to VP. So by using the scale, you measure the length of AB2. So that length will be equal to 78 mm. And when you are by using the protractor, you measure an angle with respect to the AB1 line. That is the true inclination line with respect to VP. That is the inclination of AB2 with respect to AB1. So that inclination will be 36 degrees when you're doing it in manual. So when you're doing it in the CAD, so you're going to get the true length as 78.32 mm and phi will be equal to 35.93. So this is how you will be able to analyze this problem, and as well as you can be able to draw by using the sketchbook and show all these dimensions which are given in the data has been shown here. The one which need to be identified is going to be given as the variable, and those things here which has been shown here to solve, and the answer what you got out of drawing the sketch. So this is how you will be able to analyze this problem. Thank you.